Hey, welcome to eLearning Friday. Today we're taking a look here in the lab, and you're going to watch me walk through our reactions type lab. So don't print off the piece of paper and make it available to you guys on Canvas, but don't print it off. Just get out your own sheet of paper and write down the answers to the questions on your sheet of paper, just like you would for any other homework. Here is that lab. Here's what it looks like in the hard copy. And the first thing it asks for are the 4 indications of a chemical change. We covered that briefly last semester, but even if you guys were here for a typical year, I would help you guys out with that one to begin with, just to make sure we know what to look for. So here we are, Richardson. This is LT2. I know, only our second one. We should be doing more. Working on that. This is our reaction types lab. All right, so before we even really get to question 1, we have to list the 4 types of, or 4 indications, 4 things you look for a chemical reaction. So those 4 things are an energy change. So write that down. That's usually going to be in the form of heat or light. If either of those 2 are given off or absorbed, you could have a loss of heat. Something get cold to the touch. It would also be an energy change, an indication of a chemical reaction. Next up, a color change. So if an item changes color, that's a really good indication that you've had a chemical reaction. Gas produced, usually going to let you know you've had a chemical reaction occur if a gas is produced. And the way that you're usually going to tell that most of our reactions are taking place in water, so you're going to look for bubbles. Bubbles releasing is an indication that you have a gas being produced, which is one of our 4. And finally, the formation of a precipitate, which is a solid. Now keep in mind, solid doesn't mean the whole thing just turns solid. Again, I just mentioned a minute ago, a lot of our reactions take place in water. Well, it's not like we're going to wait and watch that water freeze and become solid. Not exactly what we're looking for. What we're looking for, just like the opposite of salt dissolving. So you guys have seen salt, it goes into water, it dissolves, it breaks apart. And with the opposite of that, what if you have a liquid and you have these little tiny salt particles that kind of form and fall to the bottom of your watery solution? That would be a precipitate, and that's what we look for as one of our 4 indications of a chemical reaction. So there we go. You've got your first 4 points on this lab right there. And now we are ready for reaction number 1. You'll notice there's a couple of things you have to do for each reaction. So in just a minute here, I'm going to show you guys, I'm going to place a piece of aluminum foil. So that's elemental aluminum, just Al, plain old Al, into a test tube with copper 2 sulfate. Now, we don't have to worry too much about the volumes here. We're not doing in a quantitative lab today, just more of a qualitative lab. So I don't really care too much about the 1 milliliter, but I'm going to add copper 2 sulfate. And you guys should know what solution means at this point. We're then going to add 1 drop of hydrochloric acid. But keep in mind that hydrochloric acid is only a catalyst. It's not a part of the reaction, so don't add that to your reaction. For those of you who have asked this week what to do with a catalyst, and you remember what to do with a catalyst, feel free to put that in there. It'd be worth a bonus point if you do. But if you don't know what to do, if you have no idea, just leave that hydrochloric acid out of it. Our reaction is aluminum with copper 2 sulfate. right, so here is our piece of aluminum. Here is our piece of aluminum. Got it kind of rolled up, balled up. Notice that color there. Okay. You guys might get too dizzy. There's a test tube. I'm going to put my aluminum foil into the test tube. So there we go. We've got the aluminum foil. You can notice the color on that. Here is my copper 2 sulfate. Again, the direction said 1 milliliter, but for this lab, we're not going to be too particular. Just give that a good squeeze. There we go. And there's that nice, pretty blue color that the copper sulfate has. Think of the Statue of Liberty. Nice, pretty blue color that copper statue has. And then we're going to add, as a catalyst, just a little bit of hydrochloric acid. Don't need much, just a couple of drops. There we go. And again, don't use hydrochloric acid as part of your reaction. It's just a catalyst. It's not actually in the reaction. And it is very warm to the touch. Very warm to the touch. I feel up here, this regular glass is kind of cool, but down here, very warm to the touch where the reaction's happening. All right, hopefully I can get you guys a good look at this so you guys can see that color of the aluminum. Look at that color. I know it's a little blurry there, but there we go. There we go. Look at that color. And when we started off, we had that nice piece of aluminum foil. You guys all remember what color aluminum foil is? We'll take a look at it now. Man, why did it change that color? Now, I know you guys might be saying, hey, there's bubbles down there. Do not write gas produced. There's not going to be a gas produced on this one. I think that is simply because there's so much heat being given off that the water is boiling. But yeah, look at that color and think about that. Wow, very hot to the touch. Very, very hot to the touch there. All right, so wow, cool reaction, huh? All right, so on your sheet of paper, Part 1A, what were the indications of a chemical reaction taking place? Again, those were the 4 options we listed above. Which of those did you see, or did I tell you I felt for this reaction? Part B, so 1B, take your time, write a balanced chemical equation for aluminum, just elemental aluminum, reacting with copper 2 sulfate. Remember, hydrochloric acid is just a catalyst. So you can just forget about it. If you had no idea what to do with it, leave it out. It was not a part of this reaction. What type of reaction was it then? 1C. Remember, we've done 5 different types of reactions so far. So what type of reaction did you guys just observe? What was oxidized? What was reduced? And then finally, a quick sentence for 1E. What do you think would happen if we did the reverse of the reaction? So here we put regular aluminum into a solution of copper sulfate. What if we put a piece of copper into a solution of aluminum sulfate? What would happen and why? All right, so that is reaction number 1. Again, if you guys want to work on that, you can feel free to pause the video. I'm going to move on to reaction number 2, though. This time we're reacting magnesium ribbon with hydrochloric acid. Don't worry about the fact that it's called ribbon. That's just the description of what it is. Like aluminum foil is just foil. This is elemental magnesium. So we're looking for just Mg all by itself, and it just happens to be in the form of a ribbon. It's actually this piece of a magnesium right here came from a much longer piece. I cut it off earlier. So here's our piece of magnesium, and we're going to react it with hydrochloric acid. Again, don't worry about the actual volume. Not a lab where we care too much about the actual volumes. So magnesium reacting with hydrochloric acid. So I got my magnesium. In fact, I'm going to set this up here in the test tube block to my copper sulfate solution. Got my hands free. We'll focus it and zoom in. I'll have to hold the test tube at the same time. See that? There we go. All right, so there's our solid piece of magnesium ribbon. There it is. There's a good picture of it. That guy right there. There's our magnesium ribbon. Again, I'm going to add some hydrochloric acid. Okay. This one definitely had a gas produced. Boy, you can see it coming off there, couldn't you? Wow, it's coming off the top of the test tube. You can see it. This is a good one. Let's give it a quick feel. Maybe a little bit of heat. Not terribly hot. Definitely not as hot as the copper got. But man, look at that. A little bit of magnesium and hydrochloric acid. And again, that's really cool. You can quite see that. There's a little bit of smoke just kind of, it's not actually smoke. Cool just looking at that smoke coming off the top. Show it to you on the video though. There we definitely see it. Pretty cool, huh? Touch, quick feel. Yeah, it's definitely warm. Definitely warm. Definitely some warmth there. Again, not as hot as that first one got, but definitely feel some warmth. In reaction number 2, we just put some magnesium ribbon. That's just plain old elemental magnesium. And we mixed it with some hydrochloric acid. So that's the reaction we just took a look at there. What is the evidence you observed a chemical reaction? Again, we listed the 4 indications of a chemical reaction when we started the lab. So which of those 4 did you observe, or did I feel for you and kind of describe to you? And what happened to that piece of magnesium? What's going on with that? Part C, write the balanced chemical equation. And you're reacting elemental magnesium with hydrochloric acid. And then part D, identify what type of reaction that was. Which of the 5 types of reactions did we just observe? So at this point, you guys have a 1A, 1B, on C on your own piece of paper. One actually went all the way down to D, so check, make sure you guys got those 5 things. Again, I've got this lab posted on Canvas if you need to see the written version. And then we went on to reaction number 2, and that one has an A, B, C, and D. So take a look at those. Next, we are on to reaction number 3. Let me finish there. I can help you on question B of reaction 2 there. Happened to that magnesium? Well, look at that big long piece of it. Look how much is left. Not much at all. There's very little magnesium left. Mostly all liquid. So I don't see that magnesium, that piece of magnesium anymore. So what's our chemistry term for that kind of disappearing like that? See, it's gone. Okay, reaction number 3. Don't bother the page here. Now we are using hydrogen peroxide, period. So what kind of reaction do we work with where we have one compound? Remember, peroxide, you're going to need the back of your periodic table. I know it ends in IDE, but peroxide's from the back of your periodic table. So hydrogen peroxide by itself. What happens when we have a compound by itself? What kind of reaction is that? What are we going to produce? Potassium iodide is going to be used. I'm going to put some of that in there, but it's only a catalyst. Potassium iodide is just the catalyst. So again, don't include it. It is not a part of your chemical equation. So here is the test tube. Here is my hydrogen peroxide. Put a couple of drops in there. So we are looking here at our hydrogen peroxide, a clear liquid. Don't drink it, it'll make you sick. Looks like water, but don't drink it, it'll make you sick. And now I'm going to add my catalyst. So catalyst just kind of speeds up a reaction. Now the catalyst has a yellow color to it. So don't think we're going to have a color change. We shouldn't. The catalyst just has a yellow color to it. Aha. Look at that. That's interesting, huh? Again, don't write color change. That catalyst had that yellowish, orangish color there. But what did we have produced? So feel it here, super. A little bit of warmth. Yeah, a little bit of warmth. A little bit of warmth, but big time. What are you guys seeing there? What is the main indication there that we are witnessing a chemical reaction? Look at that thing go. All right, my work here isn't making me too crazy. So reaction number 3, again, what type of reaction did we just win? Hydrogen peroxide was the only thing we had. Yes, we had a potassium iodide, but that only speeds the reaction up. It isn't actually a part of the reaction itself. So don't include that. Just one thing, AB, arrow. So 3 has a part A and then a part B. So what did you observe happen in that reaction? What was your indication? And then what is the equation for hydrogen peroxide? And hey, look at that. I even helped you out, told you what it fell apart into. So you've already got the answers there. You just have to write the balanced chemical reaction as part of 3B. And on to reaction 4 we go. All right, so we're on reaction 4. For this one, we're going to start with a spatula tip. So that just means the very end. Again, we don't care about the actual amounts, but we're going to put a spatula tip of lead 2 nitrate and then a spatula tip of potassium iodide into a test tube. So these are going to be 2 little white salts. So I'll work with these guys for you guys here. Show you get these guys. And again, the reaction that we're doing in number 4 here is the reaction of lead 2 nitrate reacting with potassium iodide. All right, so here's my 2 test tubes I'm going to use. And again, I'm going to start off by putting just a little bit of lead 2 nitrate into one of those. Just a spatula tip. It's just a little bit. There we go. So this is what we call a spatula. It's kind of a long metal rod here. And this is kind of how we scoop salts, scoop chemicals out of their jar. So just a tip means just a little tiny bit, which is what I just got. See it there at the bottom of the test tube. Okay, just kind of a white salt. I'm going to do the same thing for potassium iodide. So again, not very much of it. Here that is. And just a little tiny bit of salt there on the edge of my spatula tip. Put that in a test tube here. There we go. You need to use the vacuum periodic table. What do you expect to happen when I mix lead 2 nitrate with water? Is it soluble? So just the lead nitrate with water. How would you know? Solubility table, vacuum periodic table. Take a look at that. Find a rule for lead 2 nitrate. What is the number of the rule? How about potassium iodide? Is that going to be soluble in water? So when I add water to these 2 test tubes of salt, will the salts dissolve? That's what this question's asking. Is it soluble in water? Yes or no? Yes or no? And again, tell me the rule number in the back of your periodic table. Got rules 1 through 6. Some of them might have several rule numbers. You might say, well, rules 3 and 6. So just state that number. Water, and we're going to see if these dissolve. So if you've looked up the rules, you know what to expect at this point. There are our white salts. Again, they look very much like the salt you put on your French fries. A lot of salts do, but let's see what happens when we add water. So that was my lead nitrate. And you can see that white salt. Well, most of it's not really there anymore, is it? By and large, it has dissolved. All right, we'll do the same thing for this one. So this is our potassium iodide. You got their salt crystals in there. We'll add some water. We'll see if they dissolve. So there we go. These salt crystals were a little bit bigger, so they're taking their time. But they are dissolving. Not a whole lot left now. Kind of camera myself here. Those are empty. I don't kind of look like there's salt in there, but there really isn't. Those are empty. They look like just water you could drink. Weird, weird light. Let's see if we better to get the black back up here. Well, anyway, both of those have dissolved. They look like pure water. They look as though you can drink them. I would highly recommend that. You never should drink anything in a chemistry lab. But there they go. They look like water, even though we know that we have the dissolved salt in there. Now, we combine the contents into one test tube. So part A is lead-2 soluble, part B is potassium iodide soluble. Now we're going to mix that. Get you guys set up so you guys can see this as good as possible. Ooh. Well, that was interesting. The camera catch that. Zoom out a little bit. You've seen the whole reaction there. That was pretty cool. I've actually never seen it before where it freezes up like that at the bottom. I'm not sure exactly what happened. I think that's awesome. Great documentation here. Okay, so we obviously had one really big evidence of a chemical reaction. My goodness, we had two things that kind of looked like water. What do we have now? Would you drink that? Also, these yellow particles, they are indeed particles. It's almost like a salt came back. So it's almost like a suspended salt right there. So it's like salt came back. We had those pieces of white crystal at the beginning, and now look at that. Hey, that's what we call precipitate. That's actually really cool. Cool image you get to see there. That's awesome. I've never actually seen it do this much. That's really cool. So that's a precipitate forming. Again, the whole thing didn't just turn solid. It's still, liquid, but you can see little particles of yellow solid in there. I'm impressed. I thought that was awesome. Sorry you guys weren't able to see it yourself, but okay. What was our evidence that a chemical reaction occurred? And then finally, part 4, write the chemical reactions for lead-2 nitrate and potassium iodide. And finally, part E, what type of reaction was that? So 4 here, we got A, B, C, D, and E. And feel free to take more room every other line, every 2 lines, every 3 lines if you need it. But that was reaction number 4. And now we are ready for reaction number 5. And for this one, I feel terrible. Almost kind of want to re-record everything, but it's been going so well so far. I haven't been wearing goggles, and I feel like an idiot. I'm going to go get some, especially for this next part. So I'll be right back. Reaction number 5. Sorry about that. Really should have had these on from the get-go. Reaction number 5, we're going to be looking at the combustion of methane. So for this one, we get to use a Bunsen burner. Hooked up. And I'm going to use our striker. That's this device here. It's like a flint and steel. And the trick is not to go fast. You know, I don't want to go back and forth, back and forth, back and forth. The trick is to apply pressure. So I push this end here, down into it, and get one good strike. One good strike. Not a bunch of bad ones. I want one good strike. Back here using these before you know it. Turn the gas on. There we go. One good strike is all it takes. You need 3 strikes. Hey, there you go. It shows up a lot better, doesn't it? Just that flame there. There you go. There you have it. That is reaction number 5. The combustion of methane coming out of our gas jets here in the chemistry lab is methane gas. We are burning it. That's our combustion reaction. So that's reaction number 5. Our last reaction is the reaction of magnesium with oxygen. So I've got that magnesium ribbon again. It's going to be tough to see. I've got the lights still off here, but I've got that magnesium ribbon. Now I'm not reacting magnesium with methane. I'm not reacting magnesium with fire. I'm just using fire to get it going. The only thing we're going to react, this is reaction number 6 here, and watch, because it happens quickly. There you go. I'm holding on to this magnesium, and there we go. That was it. That was the reaction. What did you see for that one? That was pretty cool, huh? All right, that quickly our lab came to a close, huh? So reaction 5, what did you see? What was, I didn't feel it. I wasn't going to feel it, but some of you guys can tell what it would have felt like. Again, reaction 5 was just the plain old flame. That was reaction 5. Reaction 6, then, we used the flame to get the rest of it started, but the idea was we synthesized magnesium oxide from its element. So I had that ribbon of magnesium, and it was tough to tell in the dark, but it was that same ribbon of magnesium that we used in reaction 2, so just elemental magnesium, and it reacted with the oxygen in the atmosphere. You guys saw that reaction. It's pretty nuts, wasn't it? Pretty bright, very bright, almost blindingly so. Perhaps I should have turned the lights back on before I did that reaction. So magnesium oxide was made from a little bit of magnesium and plain old oxygen in the atmosphere. Left, magnesium ribbon I put into the flame. It's not really much metal ribbon anymore. Now it's more of a salt. Again, I could scoop this up if I wanted to. We'll mix it with some water. It's that white salt I was saying. So many things look like a white salt. This one looks like a white salt now too. Magnesium oxide. There we go. Magnesium oxide, the ionic compound now. So we synthesize that from magnesium and oxygen. So part 5. Only has a part A and a part B. And then part 6, reaction number 6 here. Part A, what did you guys see there? That bright light, what was that an indication of? 6B, the balanced chemical equation for magnesium reacting with oxygen to form magnesium oxide. And then finally, another oxidation and reduction question. And that'll be your lab. It should look something like this. Again, if you guys needed more room, if you go to the backside, that's absolutely, in fact, probably preferable. Skip every other line or every third line or whatever it is, but this is what your lab should look like with answers instead of A, B, C, D. You should have, the answer there, your balanced chemical equation there, your answer there. All right, so I'm sure you guys did not enjoy this lab nearly as much as I did. It's a cool lab. Sorry, but hopefully you got to see some cool things. The different color changes, the heat changes, all that. So take a look at the lab. If you have any questions with it, make sure you're coming into office hours. This is not due until Thursday. So I will have at least 2 office hours before it's due. So if you're not going to ask in class, come visit me in office hours. But good luck with the lab. Have a great long weekend, and I'll see you guys next week.